Alrighty, guys. So, day 3 of our statistics unit. So this is going to be all about collecting data. So we are going to talk, today's pretty big on vocabulary. So we're going to talk about all of these different vocabulary definitions here. And it's a lot, okay? I'm just going to go ahead and preface with that. It is a lot, which is why I've given you these graphic organizers, okay? And I'm actually going to allow you to use these on the quiz for this section. So please have these handy. You are allowed to write whatever you want to on these, okay? Make them yours. But here's what I wouldn't do, okay? I wouldn't copy all of these definitions word for word because that's definitely not going to help you, okay? What I would do instead is just take the bits and pieces of what I'm saying and maybe put these definitions in my own words, maybe write down some examples, okay? So that way I'm clear on what each of these concepts mean, okay? So once again, don't just copy these definitions word for word onto that sheet because that's not going to help you. You will turn this sheet in with your quiz. So please make sure everything that you're writing is appropriate and no phones are allowed or any kind of technology is allowed to be used on the quiz for today. Okay, so just these sheets in your brain. You actually don't even need a calculator for this math quiz. So if you're good at vocab, today is your day. So here we go. First thing we're going to talk about, observations and experiments. So in an observation, it says the researcher simply observes the subjects without interfering. That is, the researcher has no control over any treatments the subjects may be given or which groups the subjects may be separated into. Okay, so this is literally a fly on the wall kind of situation. Okay, so if in an observation, there is a researcher, but they have no control, okay? They are literally just standing in the room observing what is happening, okay? There's not any influence from that person being in there at all, okay? Whereas in an experiment, this is different, okay? The researcher's doing more work, or they're doing work, okay? So it says in an experiment, these subjects are usually grouped using a randomized process. Different treatments are given to the different subjects, and the researchers study what happens to people in each group and study the different effects of the treatments. Okay, so example of this would be, let's say that I am a doctor or scientist or whatever. And so I've invented this new drug and I think that it helps people sleep better. Okay, so what I'm going to do is I'm going to find 30 people through some kind of randomized process, 30 people who need help sleeping. Okay, and I'm going to put them in a room and I'm going to say, hey, I've invented this new drug. I think it's going to help you sleep, okay? And then I'm going to hand all 30 of them a pill to go home and take that night, okay? Half of them are going to get my new drug, but the other half of them are going to get like a sugar tablet or something like something that would have no effect on their sleep at all. And then I'm going to survey them the next morning and ask them, okay, how'd you sleep? So that's going to be my experiment, okay? So that's how I'm going to know, did my drug work or not? So those 15 people that got the drug and those 15 people that didn't, was there a difference in their sleep that night, okay? So that's an experiment. That's how most things are tested to see if there is an effect. So next up, we have sample and case studies, okay? So sample studies are groups of subjects that gather information of a variable and are analyzed. So big thing here, these are bigger groups, okay? Usually like 30 or more, okay? So a sample study might be ACT prep, okay? Like let's say that 80 students take ACT prep each year, okay, in total. And so let's say that I am gathering information. I'm going to compare the grade that they got in ACT prep and see if it correlates to their ACT score, okay? So that totally random. I totally just made that up. But that would be a sample study, okay? I had 80-ish people. That's more than 30. And I'm gathering information on a variable and seeing if it can be analyzed, okay? And then we have case studies. So it says case studies are in-depth studies of a phenomenon like a person, group, or situation. The phenomenon is studied in detail. Cases are analyzed and solutions or interpretations are presented. So case studies usually look at a smaller sample size but over a longer period of time. Okay, so this is like doing a study but diving in way deeper. Okay, so like let's say, for instance, I'll go back to the ACT prep situation. Let's say that I chose like 5 or 10 of those students, okay? And I did a more in-depth study, okay? So let's say that I looked at their English and their reading and their math and their science grades, okay? And then I correlated that to each of their individual ACT scores. So for each section of the ACT, okay? Or maybe I even dug deeper than that, okay? So these can look a lot of different ways, but just know really the main thing to know between sample and case study is just that group size, okay? So sample study is a little more broad and bigger group, typically 30 or more, and then case study is going to be a smaller group, okay? Typically, I would say like less than 30, but even smaller than that, more like 10, okay? And just kind of looking at those people over a longer period of time, okay? Cool. Survey study or voluntary response, okay? So this is the collection of information from a sample of individuals through their responses to questions, and this is solely based on the subject's desire to participate and their honesty. Okay, so we see this a lot, okay? You're out at a fast food place or a restaurant, okay, and it has a QR code. It says, scan this QR code to tell us about your meal, okay, or to give us feedback on your day, whatever it is, okay? So this would be a survey study. Does everybody who eats at Texas Roadhouse scan that QR code and fill out their survey? Absolutely not, okay? Typically, these are going to be very biased results, okay, and we're about to talk about bias here below. But the reason for that is, let's say that you had like the best meal of your life at Texas Roadhouse, okay? Or let's say you had the worst meal of your life at Texas Roadhouse. Chances are that's probably when you're going to fill out that survey, okay, is when you're really, really happy with your service, or you're really, really angry with it, okay? Typically, if it's just been the average meal, okay, nothing to write home about, or there was no hair in your food, whatever, you're probably not going to fill out a survey, okay? In fact, you probably don't even notice that it's on the table, okay? But if you had a really good meal, really, really, really good meal, or a really, really, really bad meal, that's probably when you're going to fill this out. So once again, definitely based on the subject's desire to participate, okay? And then we've got bias. So we kind of just talked about that, but basically what this is, it says some part of the sampling or data collecting process that skews the results and misrepresents the sample and the population that's being studied. Okay, bias is honestly one of the easier things to understand. There's bias in everything, okay? There's so many different types of bias, but just some random examples, okay? So let's say, for instance, I'm taking a survey on who I think is going to win who is going to win the election, okay? So who I send the survey to is obviously going to matter, okay? So if I send this survey out to a bunch of people who subscribe to Fox News, okay, that data that I get back is probably going to be biased because I know that Fox News preferences Republicans, okay? Whereas if I sent the data to people who subscribe to CNN, okay, we know CNN preferences Democrats, okay? So there's just going to be some bias in that data. Same thing with, let's say that I took a survey on what our favorite fast food restaurant is, okay? Well, if I go stand in the McDonald's parking lot, okay, and ask people who come through the drive-thru what their favorite fast food restaurant is, there's probably going to be some bias there, okay? So it really just depends on what type of data that you're taking and how you're getting it, okay? So there's all different types of bias, okay? Other examples might be like if I wanted to know about how students feel about a new school policy, okay? Let's say that Troy implemented a uniform policy and I wanted to know how students felt about it, but I sent a survey to teachers, okay? Are teachers really going to represent the students' thoughts on the uniform policy? No, okay? Once again, totally random, but there's bias in everything, okay? So just know that there are thousands, hundreds of thousands of examples that we could keep on going on and on all day about. But we're going to keep rocking and rolling through this. So let's go ahead and flip over to that next page. All right, so here's some examples. So I want you to use your graphic organizer that you've done so far. Pause this video right here, and I want you to try these out, see if we can get them. Okay, so number 1 says a group of 10 mice is given a new vitamin that is to promote brain growth. They are given a variety of difficult mazes to complete and are studied over 4 years. Okay, for this one, you should have said case study. Okay, reason being, it's a small group. Okay, over a longer period of time, 4 years. Okay, that's how long we're studying them. So that would be a good example of a case study. Okay. Number 2, a QR code is given at the bottom of a receipt that allows customers to rate their service. Definitely going to be a voluntary survey. Okay, survey voluntary. Not everybody's going to scan that QR code. In fact, most people don't. Okay, but they might, especially if they've had really good or really bad service. Okay. Number 3, 2 groups of students are given the ACT, then one group is put in an ACT prep boot camp for 2 weeks, and then both groups are retested to compare results. Okay, so this is kind of like that placebo. Because one group is getting the experiment, one of them is not. Okay, so this would be experiment. Okay. Number 4 is a group of students is curious to see if students wear their mask correctly. You can tell that these notes were made back during the pandemic. They stand at the door and tally yes or no as they enter the building. Okay, this would just be observation because they're not actually asking students anything. They are just simply observing and tallying yes or no. And then lastly, each student is asked to report the number of hours they work a week and then the number of hours that they study a week. And then those results are studied. So this would actually be a sample study. Okay. It doesn't say how many students there that we did study, but just know that this would probably be a larger amount than 30. So types of sampling. Okay. Flip your organizer over. So this is the other side of that. And once again, don't write these definitions down word for word. Just summarize, write them in your own words, write down some examples, whatever you got to do. Okay, so we're going to start with SRS. So each member of the population has an exactly equal chance of being selected, and the process of choosing the sample is purely up to chance. Okay, this is used within most other types of sampling. That's important. But a purely SRS would be something like, for instance, drawing names out of a hat or using a computer program to randomly select a number of subjects. Okay, so anytime that a computer is involved, it is SRS. Okay, if we're talking bias, using a computer to randomly pick or randomly take a sample is the least amount of bias that we could have. Okay, so computer program, always going to be SRS. And once again, this is when there is an exactly equal chance. Okay, so like winning the Powerball. Okay, everybody that buys a ticket for the Powerball, those Powerball numbers are computer generated. Okay, so there's no bias in that. Everybody has an equal chance of winning. Okay, it's just purely up to chance. Next up, we have stratified. So this is when the population is divided into groups. We call them strata. That's another word for groups. Depending on a characteristic or variable that may affect the study. Then a certain number of each group is chosen using SRS. So once again, SRS is used in other types of sampling. And this ensures that each group is represented in the study. Okay, so really the big thing is here, these groups that the population is divided in, it's dependent on a characteristic or a variable. So for instance, okay, let's say that I wanted to send out a survey, but I wanted to send it to an equal amount of people per grade. Okay, so the first thing I'm going to do is divide my group into grade levels. Okay, so if we're talking here at the high school level, we'd have 10th graders, 11th graders, 12th graders. And then I'm going to send my survey to the exact same amount of people out of the grade levels. Okay, so whether that be 50, 60, whatever it is, okay? I would pick from the grade levels using SRS, okay? Another example of stratified would be, okay, I wanted to send out a survey, but I wanted to send it to an equal amount of girls and an equal amount of boys, okay? So I would divide my group by gender, okay? So that would be, once again, strata, so depending on a characteristic or variable, so gender, and then I would randomly select from each of those genders. Okay, so once again, that's how we would do stratified. And then we get into cluster, which is very, very similar and often confused with stratified, okay? It's almost the same, but this time you're dividing first primarily by geography. We're dividing into what we call clusters, okay? So once again, that is by geography. So if I were doing a survey, and let's say I wanted to send it to 20 people from each state, okay? So I'm first dividing my population by state. So once again, that'd be geography. And then I'm sending that survey to 20 people in each state. Okay, that would be an example of cluster. Same thing with other locations. So let's say that I was going to send it to, let's say, all of the history classes here at Troy Buchanan. Okay, so once again, by location, okay, geography location. So that would be each of those different classrooms. I would first divide students into each history room, and then I would send my survey out to 5 people from each room or whatever it was, okay? So just know the difference on characteristic or variable for stratified, and then geography or location for cluster, okay? One thing too here, it says, this is usually an easier task to complete, but is only reliable if the clusters are a fair representation of the population, okay? So that's where we get into like the bias, okay? There's bias in everything. So like, let's go back to my example of sending the survey to all of the students that are in history class right now, okay? It's not necessarily going to be a fair representation because some students might have not taken history. They might not have it on their schedule this year. So there might be some bias in that, okay? So just think of when we're talking bias that there is bias in pretty much everything, okay? And then we get into systematic. So this is just simply applying a rule to find a sample, okay? For instance, making a list and choosing the nth name on each time, or choosing the nth name each time. So the SRS portion of this is usually applied at the beginning to see where we start. For instance, having a list of TBHS students and choosing every 50th name after randomly choosing to start at number 17. Okay, so that would be systematic. I developed a system, and that is what I'm going with. So that's a good example there that's already in there. And then convenience, this is not SRS, okay? This is the only type that doesn't have any SRS in it. It is simply using whatever is easiest to obtain. So if I want to take a poll on what are TBHS students' favorite sports, okay? If I just gave this poll to all of the students sitting in my classroom, okay, that would be really convenient for me, okay, because I don't really have to do any work. That's really easy for me to obtain that data. But just know that there was no SRS in that, okay? So there was no randomly selecting students and getting accurate data. There's a lot of bias when it comes to convenience sampling because, once again, it's just me doing whatever the easiest is for me to obtain, okay? If I were, back to the election, if I were taking a poll on who's going to win the election and I just go to the basketball game, okay, and I just stand at the door and I just ask people as they walk in, okay, would that be a very accurate depiction on who's going to win the election, just standing and asking people at a Troy Buchanan High School basketball event, okay, in mid-Missouri? No, probably not. There's going to be a lot of bias in that, okay? It may not be a great sample of who is actually going to win the election, and it's very convenient for me to just obtain that data, okay? So once again, just know that it's a very biased type of sampling, but sometimes it's the only option that you have if you don't have access to SRS or other types of sampling. So I know that was a lot of words, very word heavy, but please make sure you're filling out that graphic organizer. And what I want you to do now is go and on the next page, look at those examples there, those 6 questions that it asks, and we will discuss those next. So go ahead and pause here and fill these out. Okay, so a group of students want to gather information about working while in school for students at TBHS, and what type of sampling would you use in each of these? Okay, so students get a list of all students by grade, and then randomly select 20 from 10th grade, 20 from 11th grade, 20 from 12th grade. That's your sample, okay? Hopefully you said stratified. So we divided that population into strata, so based on a characteristic, which in this case was grade, and then we used SRS after that, okay? Number 7, the students get a list of all the classroom numbers and randomly pick 4. And then all the students in that room during 5th block are the sample, okay? This would be what we call cluster, because I'm grouping by location, which would be numbers, classroom numbers. And then I'm randomly picking from that. Okay, the students get a list of all the students at TBHS, and they randomly decide to start at the 20th student and then choose every 25th student on the list. When they get through the list, that's the sample. So this is definitely a system. We call this systematic. And then the students get a list of all the students at TBHS and have the computer generate 40 names randomly, and that's the sample. That is pure SRS, okay? Once again, when that computer is involved, that's the least amount of bias that we can have. And then lastly, the students in each group ask their 5 friends to be in the sample. That would be very convenient for them. Okay, so we'll call that convenience. And then last but not least, it says to discuss any biases that could occur in 6 through 10. So number 6, when we're talking stratified, okay, in this scenario, we listed students by grade and then randomly selected, okay. There could definitely be some bias here, okay. Let's say that there's not an equal number of students per grade. Okay, that would definitely affect your chances of being chosen for this survey. If there were only 6 or let's say 400 sophomores, but there were 500 juniors and 600 seniors, okay, that's definitely going to affect your chances. Wouldn't be equal for every single student, okay. And then let's say cluster. So for this scenario, list of all the classroom numbers, randomly picking 4, and they're all in their 5th block, okay. Is that really fair to only give a survey to a 5th block? Okay. What about the students who are sick, who are absent? What about the students who have early release or maybe are at tech, okay, and they're not even on campus, 5th block, okay? So that would be examples of bias for that. Okay. Number 8. So the students get a list, and then they randomly pick that system. Okay, even though I'd say that the bias on this is a little less than 6 and 7 for sure, how'd they pick that order? Okay, how was that order decided? Because that could be a little bit of bias. What if this was all alphabetical, and your last name started with an A? Okay. That would kind of suck, because chances are if they're starting at the 20th student, you might not even get a chance there, okay? So definitely could be some bias there. And then we've got SRS. There's really no bias when it's just all computer, okay? So that would be that. And then convenience, there's thousands of examples here. Convenience is always going to be the most biased. So students in each group ask their friends. Well, duh, okay? That's definitely going to be biased, because that would be not an accurate depiction of whatever they are trying to study. So that is a lot. Once again, a lot of words, but hopefully you got some good notes down. Continue to take some notes, okay? So get on if you want to check out your pal Google. And Google some examples, or just look at definitions. Don't try to over confuse yourself or over think this stuff, because it can be really easy to do that. But when you're ready, you will take this quiz for today. So good luck. Thank you, and I appreciate you guys.